Welcome back to this new lessons. Is the lesson about power series, but now we don't do manipulation on the geometric series to obtain a representation of in power series of other functions. We just go and we use Taylor polynomials and Maclaurin polynomials to find the power series representation of different functions. So let's go to do these problems. We start with this problem, interval of convergence, definitions. So problem 1 says, show that the interval of convergence of this power series, summation of x to the n divided by n factorial, this power series is e to the x to the, this is the representation. It says show that the interval of convergence is for all x, is from minus infinity to infinity, is for all x. What I will do, well, do the ratio test and find the interval of convergence. What it says the ratio test, if this limit is less than 1, you can find the interval of convergence. Let's go to do it. What is a sub n plus 1? Is x sub n plus 1 divided by n plus 1 factorial divided by a sub n. If you make the limit, this is the limit of x, multiply, this limit is the x, multiplied by the limit, when n goes to infinity of 1 divided by n plus 1. This goes to 0. When n goes to infinity, this goes to 0. The x doesn't go anywhere. The x is the x that you are going to plug in. So x by 0 is 0. So this limit is less than 1 for all x. So because it's less than 1 for all x, this power series representation will converge for all x. And the problem is solved. Let's go to the next problem. It says, find the interval of convergence of this series. This series, you need to know, is sine of x. So sine of x, it converges in all, they ask you to see that it converges for all x. So this is the power series of sine of x, and we are going to prove that it will convert for all x. If we do a sub n plus 1 divided by a sub n, you will find this limit, x squared divided by this denominator. So this will be x squared multiplied by the limit when n goes to infinity of this expression, of this denominator. This denominator is like something n squared. So for sure it will go to 0 when n goes to infinity. So it will be x squared by 0. So x squared by 0, whatever x you put it, you plug in, multiplied by 0 will be 0. But 0 is less than 1. So the limit is less than 1. So the limit converges for all x, because whatever you put the x, it will be 0. It will be less than 1. So it will converge for all x, including x equals 0. For x equals 0, it converges to 0. Okay, this problem says use the definition of the Maclaurin series to derive the series for the cosine function. Okay, the definition of the Maclaurin series is that the function cosine of x is f of 0 plus f prime of 0 divided by 1 factorial by x plus f second of 0 divided by 2 factorial x squared. Who is f of x? Cosine of x. What is f of 0? F of 0 is the function evaluated at x equals 0. What is cosine of 0? Is 1. What is f prime of x? Minus sine of x. What is f prime of x evaluated at the point x0? X equals 0. Well, minus sine of 0. Sine of 0 is 0, minus sine of 0 is 0. So the number that you will find is 1, 0, minus 1, 0. So you apply 1, 0, minus 1, 0. So the power series is 1 minus 1/2 square plus x4 divided by 4 factorial minus x6 divided by 6 factorial, or this cosine of x can be written, this is the Maclaurin polynomial center at x equals 0 that never ends. It never ends, plus x8 divided by 8 factorial, and can be written like the summation from n equals 0 to infinity minus 1 to the n, x to the 2n plus 2n, because I have to cover the even power, because cosine of x is even, is an even function, it will appear the even powers here. So minus 1 divided by 2n factorial. 2n factorial. You can check, plugging different values for n, that you will find 1 minus 1 half x squared plus 1 4 factorial x4 plus minus 1 6 factorial, etc. So this is the power series and the problem. Let's go to the next problem. The next problem is, say, use the definition of a Taylor series to find the series for f of x equal 1 divided by x centered at c equal 1. So it's the Taylor, it's not the Maclaurin polynomial. Take it to infinity is the Taylor polynomial, take it to infinity. What is the Taylor polynomial? Taylor polynomial has this expression. So evaluating the function at the point x equal 1, the derivative of the function at the x equal 1, the second derivative of the function at x equal 1, you will obtain 1 minus 1, 2, and 6. So it will appear 1 minus 1, 2, and minus 6. Okay, minus 6 factorial divided by 3 factorial. Okay, so this is the Taylor polynomial. Let's go to do it with the time. So the Taylor polynomial, or the series, the Taylor series is the Taylor polynomial taken to infinity. So let's go to do it. This is f of c plus f prime of c divided by 1 factorial multiplied by x minus c plus f second of c divided by 2 factorial divided by x minus c squared. So f of c, f of 1. What is f of 1? F of 1 is 1. Plus f prime of 1. F prime of 1 is minus 1. So it will be minus 1 divided by 1 factorial. Multiplied by x minus c. C is 1, because it says that you will have to find the Taylor series centered at 1. X minus 1 plus f second of c. F second of c is 2. 2 divided by 2 factorial is 1. Well, we leave it. 2 divided by 2 factorial. X minus 1 squared. And now in the following term is f3 of 6, f3 evaluated at the point 1, which is minus 6 divided by 3 factorial. 3 factorial is 6, multiplied by x minus 1 cubed. So it would be the series x1, x minus 1, plus x minus 1 squared, minus x minus 1 cubed, plus x minus 1 4, minus x minus 1 fifth. So this is the series, and it can be written like minus 1 to the n, summation from n equals 0 to infinity. Now it's x minus 1 to the n, when n equals 0, to the n. When n equals 0, it appears the first term, 1, because when n equals 0, well, n equals 0, this raised to the 0 is 1, minus 1 to the 0 is 1. When n equals 1, minus 1 to n equals 1 is minus 1. Minus x minus 1 raised to the power 1, it appears this term. When n equals 2 will appear this term. When n equals 3 will appear this term with the minus sign. When n equals 3, minus 1 raised to the power 3 is minus 1. That's why this appears this minus sign. So the alternated series is series 1, x minus 1, plus x minus 1 squared, minus x minus 1 cubed. This alternated series represent which function? It represents a power function whose function is 1 divided by x. So 1 divided by x is the representation of this function in what interval of convergence? Oh, you cannot go to the 0 because at x equals 0, this function will not have any value. It's not defined. 1 divided by 0 is not defined. So the interval of convergence for sure should start at 0, comma, and the series is centered at 1. So it could be 0. If it's centered at 1, the radius is 1. It could be 0, 2. Now, for sure, this is open interval, 0. And this one, I don't know if it's open or closed. What we will do? Well, we will plug in x equal 2 here, and the series that will appear, it will be 1 minus 1. 2 minus 1 is 1, plus 1 minus 1. Oh, it will not converge. 1 minus 1 plus 1. So this is the interval of convergence of this sequence. The sequence represents the function 1 divided by x. And the integral of this sequence is the integral of this function, which is natural log of x, will be the integral of this function and will represent the natural log of x. So natural log of x plus c, if you make the integration, natural log of x plus c, if you make the integral here and the integral here, natural log of x plus c will be the summation from n equals 0 to infinity of minus 1 to the n, x minus 1, x plus 1 divided by n plus 1. And to find what is the c, you plug in the number 1, x equals 1, and you know the natural log of 1 is 0, so 0 plus c, if you plug in the number 1 here, 1 minus 1 is 0, so it's 0, so c is 0. So we found that from the previous series, from 1 divided by x, which is equal the summation from n equals 0 to infinity of x of minus 1 to the n, x minus 1 to the n, from this series that represent the function 1 divided by x, we have found that natural log of x is being represented by a power series that is n equals 0 to infinity minus 1 to the n, x minus 1 to the n, the n plus 1 divided by n plus 1. And of course, this is centered at x equals 1. And the interval of convergence, or the interval of convergence here is x is more than 0, between 0 and 2. And this interval of convergence, for sure at 0 will be open. X, and we make it the integral, we may gain an endpoint, the 2. To see if we really gain the endpoint, we do like this. When x equals 2, 2 minus 1 is 1. 1 raised to the power n plus 1 is, it depends on n, is 1 minus 1 minus 1, 1. So let's go to do it. So when n equals 2, when x equals 2, when x equals 2, what will be this series? Will be the summation from n equals 0 to infinity of minus 1 to the n. When x equals 2, it will be 2 minus 1. 2 minus 1 is 1. 1 n plus 1. So 1 n plus 1 will be 1. Divide by n plus 1. Divide by n plus 1. What will be this series? It will be, when n equals 0, is 1 divided by 1. Plus, when n equals 1, is 1 squared. 1 squared is 1, and it appears here at 2, so it will appear when n equals 1, it will appear minus, so it will appear minus 1 half. When n equals 2, it will appear plus, because n equals 2 will mean minus 1 squared, which is positive. 1 raised to the power 3 is 1, plus 1/3. Oh, this is the alternated series, so we gain the point. So this is the interval of convergence. Let's go to the next problem. This problem says use the definition of a Taylor series to find the series from the function e to the x, but now the function is centered at c equal 1. So we have to find, this is the function e to the x. E to the x is 1 when x equals 0, but he said that you should find the Taylor series when x equals 1. When x equals 1, this is e. And I have to find the Taylor series from at the point x equals 1. So the term that will appear will be x minus 1. So the Taylor polynomial will be this summation. The summation, if I plug in the numbers, I will find e multiplied by a. Okay, everything like this. Let's go to do it. Okay, the Taylor series will be for the function e to the x centered at the point x equals 1 will be f of 1 plus f prime of 1 divided by 1 factorial multiplied by x minus 1 plus f second of 1 divided by 2 factorial x minus 1 squared plus f third of 1 divided by 3 factorial x minus 1, 3. So we need to find who is f1, f prime of 1, f second of 1, but because the function is e to the x, when x equals 1, the function f of x is e to the x, so f of 1 is e. And f prime of x is also e to the x, so f prime of 1 is also e when x equals 1. So all the coefficients that are here are e, are the number e. So what is the Taylor series? F of 1 is e, plus e divided by 1, x minus 1, plus e divided by 2 factorial x minus 1 squared, plus e divided by 3 factorial x minus 1 cubed, and keep going for infinity. So this is e that multiply 1 plus x minus 1 plus 1 divided by 2x minus 1 squared plus 1 divided by 6x minus 1 cubed, and keep going forever. And how I will write this in a notation? So it will be e that multiply to the sum from n equals 0 to infinity of x minus 1 to the n divided by n factorial. And this is the Taylor representation of the function e to the x centered at x equal 1. So now we do this problem. It's a find the Maclaurin series of the function e minus 3x. You can do it in the standard way, but if you use our result that e to the x is 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus x to the n divided by n factorial, you can find more easily the Taylor representation of e minus 3, the Maclaurin representation at c equals 0. If you substitute the minus 3x by the x on this expression, it will be 1 plus, when I see the x, I put minus 3x. When I see the x, I will put the minus 3x squared divided by 2 factorial. When I see the x, I will put minus 3x cubed divided by 3 factorial. And when I see the x, I will put the minus 3x to the n divided by n factorial. So this is the power series representation of e minus 3x done by starting with the power series of e to the x. Okay, let's go to the next. The next problem say find the Maclaurin series of the function sine of x. So we do the same thing. Sine of x is 1 minus x, sine of x is x minus x cubed divided by 3 factorial plus x5 divided by 5 factorial. Sine of x is the summation from n equals 0 to infinity of minus 1 to the n. Now x raised to the even power 1, 3, 5. So this is 2n plus 1 divided by 2n plus 1 factorial. So this is sine of x. If I want to find sine of 3x, what I will do? Wherever I see x, I put a 3x. 3x minus 3x cubed divided by 3 factorial plus x plus wherever I see an x, I put 3x. 5 divided by 5 factorial plus minus. So it will be here, it will be the summation from n equals 0 to infinity minus 1 to the n, and wherever I see an x, I change it for 3x. So it will be 3x, I'm watching here, 3x, 2n plus 1 divided by 2n plus 1 factorial. And this is the power series representation of sine of 3x based on the Maclaurin's power series representation of sine of x. Okay, and this, it's a use this identity sine square of x. This is a trigonometric identity to find the power series representation of sine of x centered at x equals 0, because it's the Maclaurin. So is not difficult because you know that sine square of x is 1/2 minus cosine of 2x, so I will find the power series representation of cosine of 2x. I will plug in, and this will be the sine square of x, the power series representation of sine square of x. So if you do it, you will find all this term. Okay, you can do it. It will be very easy to find cosine of 2x based on cosine of x. And on the problem 9, it says find the power series representation of e to the x multiplied by sine of x. So you multiply two series. This series is the series centered at 0. This series is the center of sine of x centered at 0 also. So you multiply two series, and now you have to be careful finding the multiplication, putting in the increasing order of x. So the first term that will appear is the x. So this will appear this x. Is another the following term that will appear is when I multiply this x by this x. So it will be x squared. So x squared. The following order that will appear is when I multiply the 1 by the x cubed. So it will appear minus x cubed. And the following one, the x5, will appear when I multiply this term, x4 divided by c by x is x cubed. So we have to multiply. Let's go to do the multiplication. So I will do this by this will be x1. There is another x1? No. So this is the term. Now, this by this is x squared. There is another x squared? No. Another multiplication that produces x squared? No. So this is this one. Now I will multiply this by this, and this is x cubed. So this will produce x cubed divided by 6 minus x cubed divided by 6. But there is another term that will produce x cubed divided by 6. Let me see. Another term, x squared by x. So it will be plus x squared divided by 2 multiplied by x. So the x cubed term will be minus x cubed divided by 6 plus x cubed divided by 2. So it will be minus x cubed divided by 6 plus 3 times x cubed divided by 6. So it will be 2 times x cubed divided by 6. So it will be 1/3 x cubed. So the cubic term that will appear is 1/3 x cubed. So if you do it with some strategy to make the order, it will appear the terms in crescendo order. X to the 1, x squared, x cubed, x5, x4. You see, there is a jamming x4. Why there is no x4? Because if you multiply this by this, or this by this, it will produce x cubed. If you multiply this by this, x squared, there is an x4 here. X multiplied by x cubed. This is an x4. So this is wrong. It's missing the term x4. Or it's cancelled. No. This by this, I don't see that it's cancelled. I think that it appears. Here x4, this is x4, there is one x4, no, x cubed by x is x4 divided by 6. X cubed by x is x4 divided by 6. and x multiplied by x cubed divided by 6, this one is also x4 divided by 6, that it will cancel. No, it will not appear the x4. So this is instead of considering, you can do the function f of x equal e to the x sine of x and evaluate f prime of 0, f second of 0, f third of 0, and construct the Maclaurin polynomial. Also, you can do it like this. Well, I think we finished. No, we have not finished. There is an integral of cosine of a square root of x. So to do this integral, what we do is we know what is the Maclaurin series for cosine of x. The Maclaurin series for cosine of x is 1 minus x squared divided by 2 plus x4 divided by 4. Cosine of x is an even function, so it will appear the even exponents. Okay. But the problem says cosine of a square root of x. So it will be 1, wherever I see, I will put a square root of x squared divided by 2, plus wherever I see the x, I will put a square root of x divided by 4 factorial. What will be this? Cosine of square root of x will be 1 minus x divided by 2 plus square root of x squared is x squared divided by 4 factorial. 4 factorial is 4 by 3 by 2. 4 by 3 by 2 is 12, is 24. So it will be 1 minus x divided by 2 plus x squared divided by 24. So because maybe I don't know the antiderivative of cosine of a square root of x, what I will do is I will use this Maclaurin series to integrate. So it will be very easy integration because now it's a polynomial. So we integrate 1 minus x divided by 2, x squared divided by 24. The integral of 1 is x. The integral of x divided by 2 is x squared divided by 2, multiplied by 2 is x squared divided by 4. And the integral of x squared divided by 24 is x cubed divided by 72. If we evaluate between 1 and 0, we obtain the result for the area below, under the curve cosine of the square root of x between 0.5 and 1, and this area is 0.322. So this kind of technique is useful when it's difficult to find the antiderivative. When it's difficult to find the antiderivative, you use this method. Okay, we leave it here. Good night.